Okay, just trying to help you guys out. You want to find this handout, and it should say at the top in your notebook, or should say in your binder, an example describing motion from graphs. This is in lesson 5. It's the first one, the intro one. And so we have been graphing data. We've been graphing data of like data collected that's all kind of part of one experiment, or evaluating how does one variable change with another. But we just introduced this idea of frame of reference, and we've looked at position time graphs. But we haven't really talked about like what they mean and how to describe motion from them. We also, I introduced these motion maps. I didn't call them that, but remember the dots with the arrows when I was introducing vectors, and it was like a slow moving object or a fast moving object. So that was a way to describe the motion of an object, but it was just with dots and arrows. So how do we look at a graph and talk about how that object could be moving? That's what today's lesson is on. Okay, this is part of the skill set. So this unit is on intro to motion and graphing and measurement. And so now we're shifting into, honestly, like how to describe motion. And so there's kind of like 4 skills. There is describing motion from a graph, describing motion from a data table, describing motion from a motion map, and describing and then taking a written description and doing a motion map or doing a graph. So they're all interrelated, and it's kind of like different ways to talk about how an object is moving. And that's what we're going to kind of work on over the next couple days. So this graph here, if we take a look at it, has time on the x-axis, it's in hours, and has distance on the y-axis, and it's in kilometers. So it's the slope of the line, change in y over change in x, would just be kilometers per hour. That's probably right a unit. Like if I change it to miles per hour, we're probably talking about like a car moving or something. That would be like usually a time when we would use those units, just like big picture. But if I say kilometers per hour, hopefully in your mind, if I say miles per hour, in your brain, you're thinking how fast something is going. That's a speed. The slope of a position time graph is speed. We want to be able to read this graph, and I want you to notice that there are kind of 2 slopes. There's one that's a positive slope, and then there's one that's a negative slope. Okay. When we describe a motions object, there's always some reference point. So you will typically see like a 0, 0 point on a position time graph. And that would be like, let's just say this is your house. Okay. It's some reference point. It could be the starting line of a race. It could be the school. I mean, whatever somebody decides is like the reference point, that is position 0. And an object could be at that reference point. That object could be to the left of a reference point. It could be to the right of a reference point. It could technically be like up, down, sideways, or whatever. But we will just consider objects like to the left or to the right, or up or down from a reference point for simplicity's sake. So this object did not start at the house. Its starting position is right here, because this is at time 0. Okay. And it was positive 5 kilometers away from the reference point, which I'm just going to call your house. Okay. And let's just it helps sometimes with students to make kind of a story. So let's say that you're at school and you live about 5 kilometers or 3 miles away from school. Sound good? Okay. And so this is where you are, you're located from your house. So your mom calls you, and your mom's like, where are you at? And you're like, I am 5 kilometers away, 3 miles away from home. And then your mom's like, well, where are you going? You're like, I'm going to go to my friend's house. Okay. So the object started at 5 kilometers away, and it's important that we put that positive, because that's going to communicate a direction. because you could be 5 miles north of your house, 5 miles south of your house. In this case, it's communicating a direction. This is all in quadrant 1, so it will be positive values for position, but it doesn't have to be. Your friend's house is further away from where you are right now, okay? And it's 10 kilometers away from your house. So going from where you are right now to your friend's house is going to put you at a position further away. How do I know it's further away? Because the slope of the line moves away from the origin. Okay, so it moved, like literally that line is going further away from the reference point. From this point to this point, that object moved, but we follow the y-axis, position went further away from the reference point, the 0, 0. How far did it move? Well, it's the change in the y. So it, for this first segment, okay, for this first segment, it started at 5 and ended at positive 10, okay? So let me change colors here. It moved, you can just count like it moved 1, 2, 3, 4, 5. It's the change in y, okay? So it moved positive 5 kilometers. This is your change in y. Well, how long did it take? That's going to be the change in x, since x is time. So how long did it take you to go to your friend's house? Well, I probably shouldn't have picked hours, but 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's, yes, I know it's from 0 to 9, but it's just good to count from that whole segment. So this is, it took 9 hours. So 9 hours to do that. And it's just good to describe motion fully and say, like, where did that object start? You can solve for that, like without this line, like if you started at 5 kilometers away, moved positive 5 kilometers, you could deduce that the object is now positive 10 kilometers away. Or you can read it at where did the object stop for that segment of the graph. So that's one way to describe motion. It's not the most specific. So you're going to see that on your note sheet versus what I have is going to be a little different. So you're going to have to mend it. So we also have the second segment. This object did not end its route here. It did move in this first segment from 5 to 10 kilometers, but then it went somewhere else. So maybe you went to another friend's house and whatnot. So you're going to see in red here. Let me move this whole graph down. So rather than use like toward or away, which is a good starting point, we actually want to talk about to the left or to the right, okay? If slope is positive, object is moving to the right. That's how we're talking about relative motion. So we have to kind of define what is positive, what is negative. So on a position versus time graph, if the slope is positive, we're going to say the object's moving to the right. We're going to associate, I mean, it could be up to, but we're pretty much going to talk about objects moving like on the ground, not in the air yet. And then if slope is negative, object is moving to the left. And this helps because an object could be moving to the right and away from the origin. It could be moving to the right and towards the origin. Just depends on where it is relative to whatever the reference point is. So Toward or away works really well if you are only talking about objects that can kind of move on one side of a reference point, but if they can go on both sides of a reference point, it's not as clear. So for segment 2, okay, here to fully describe this object, it did, wherever it stopped at the last segment is where it's starting for this one. So it's starting at positive 10 kilometers. So just reading the starting point there. It moved either to the left, to the right, or stood still. So you have a negative sloping line here. It is moving toward the origin. It is getting closer because you can see it starts at positive 10 and its ending point is at positive 8. So this is the start for segment 2, the end. But if it was at positive 5, and then we're saying that that was like to the right, and then it moved 5 kilometers to the right, if it was coming back closer, that would have to be moving to the left. And that's a negative sloping line. So it's now moving to the left. How far did it move? It moved. So it went from 10 down to 8. So it moved negative 2 kilometers. The negative just communicates direction. It's the same, it's communicating like to the left, okay? And it did that, so it went, you can kind of look at it, moved 1, 2, that's the change in Y. And then it did that in 1, 2, 3, 4, 5, 6. So negative 2 here, and then 6 hours. Now, this is the same as saying it moved at a speed of, so if we actually find the slope of the line, okay, so slope is speed. So if we take this negative 2, so right, slope is the change in Y over the change in X. So it went down negative 2 kilometers in 6 hours, right? So you just, we're not going to do it as a fraction, so we're not going to do negative 1/3. So actually like divide those, okay? And you will get, it moved negative 0.33 repeating. So they moved 1/3 of a kilometer per hour. So that's its speed. It's the slope of the line. And it did that for 6 hours. So that's still the same. It moved 1/3 of a kilometer every hour, and it did that for 6 hours. That's equivalent to what we said here. This is more specific. That's what we'll work towards. But you first have to be able to read the change in Y over the change in X, which is then you could calculate the slope and say how fast they were moving and for how long they were moving that speed. It stopped at, well, you want to then read the final position, which right here, it stopped at positive 8 kilometers. So it's reading the X and Y axis and it's describing the motion. Now, simplifying this object moved to the right, positive 5 kilometers in 9 hours. It was probably not you, it's probably like a turtle or something. It then turned around and then started moving back the way it came for the next 6 hours. It did it at a slower pace even, and it moved 2 kilometers in 6 hours, okay? It's breaking each segment down. Just want to pause. Any questions?